This is variation on the Johnson and Jackson Pythagorean Theorem. And as you know, in my previous video, what did we do? Well, we took this kind of a trigonometric setup that Johnson and Jackson have done, and I tweaked it a little bit. Instead of using the sine 2ab over sine 2a, I'm using more of an area approach. Of course, we are using this u, which is an infinite sum, a geometric series. And so that's kind of what I will do today. So my approach will be to use the area A1, that's this big triangle. It consists of A2 and A3. A2 is this triangle, and A3 is this triangle here. And so the difference is now how I compute A2. Instead of base times height is u times this height, what I will do is, I will just do a infinite sum of infinite areas of these triangles. You've got this triangle plus this one, plus this one, this one, this one, ad infinitum. So that's going to generate another power type series, not power series, but a geometric series. And so, okay, what's going to happen is that these will be the same. It's A2, basically it has to add up to whatever this is, that's what A2's got to be. But using this approach of adding up these individual triangles, the areas, and there's an infinite number of them. So we're going to add up all of these areas here of these similar triangles. And that simply is 1/2 A2 is 1/2 times 2a plus 2a squared over b plus 1/2 times 2a squared over b times 2ab squared plus 1/2 of 2a third over b squared times 2a to the fourth over b third plus ... forever. That's a limiting process. So we can simplify this. The 2 cancels the 2, collect your terms, and it's 2a third over b plus 2a fifth over b to the third plus 2a7 over b fifth plus ... forever. Which simplifies further if we factor out the 2a third over b to 1 plus a squared over b squared plus a fourth over b fourth plus ... which is an infinite series, the same as this one here. It's a limiting process, and it gives us this result. It basically gives us 1 over 1 plus a squared over b squared, and then you simplify that, it becomes b squared over b squared minus a squared, and simplify further, it's 2a third b over b squared minus a squared, and that must equal this, and it does, because take a look, we cancel this out, the c cancels out, you got 2a third over b squared minus a squared. So this simplifies to this, then you cancel out the b squared minus a squared, and you get your answer of c squared equals a squared plus b squared. So that's a simple proof. It's a variation on the Johnson and Jackson Pythagorean Theorem. And I'm using more of an area approach. You know, there's a little bit of trig here, setting this thing up. That's their setup. These are similar triangles. So I'm using that part of trig, but that's about it. Then I'm using this u as infinite power series, or geometric series, which is this thing, a limiting process. That's calculus. And then finally, a composition of areas. A1, this big one, is composed of A2 plus A3, and so we're attacking it from that. Another proof, another variation. There'll be plenty of these. Thanks. See ya.